Let's look at task scheduler problem. Given a character array representing tasks CPU need to do, it contains capital letters A to Z where different letters represent different tasks. Tasks could be done without original order. Each task could be done in one interval. For each interval, CPU could finish one task or just be idle. However, there's a non-negative cooling interval n. That means between two same tasks, there must be at least n intervals that the CPU are doing different tasks or just be idle. You need to return the least number of intervals the CPU will take to finish all the given tasks. For the given input example of 3A instances followed by 3B instances with a cooling period of n equal to 2, the output is 8. This is because you first go about completing one instance of A, and then since no two same tasks can be done with, within an interval of n, which is 2 in this case, we go about doing B, and still an interval of 2 has not been reached, so we keep the CPU idle, and similarly go about doing another cycle of A, B idle, and finally complete the remaining two instances of A and B. So that accounts for 8 number of intervals that the CPU will take to finish all the given input tasks. Since the problem mentions that tasks could be done without original order, one strategy would be to find the frequency of the given task. So for that we can go about declaring an array of tasks equal to, that's the input. So we can go about naming it as frequency equal to new int of 26, and for each of the given tasks in the input array, we can go about computing the frequency as in this way. We'd have the number of instances of each task from A to Z in this frequency array. Now, since it can be done in any order, not necessarily the original order, we can go about doing it in a greedy manner of completing the tasks that have the maximum number of frequency occurrence first. Now to achieve this, we'll declare a priority queue that functions as a max heap of size 26, since there can be potentially 26 different tasks. To function as a max heap, we invoke collections.reverse order. Now we go about adding the frequency of the number of occurrences of each task to this priority queue. So let an enhanced for loop. If the frequency is non-zero, we go about adding it to a priority queue. This way, now a priority queue would have maximum number of, we would have the frequency of the number of occurrences of each task in a max heap fashion. In order to account for a particular instance of a task to be completed, we need to iterate through this priority queue until it is empty. Each time we need to poll from this priority queue to account for that particular instance of the task to be completed by the CPU. Now, poll from the priority queue, and once once we poll a particular number of frequency of a particular task, the remaining instances has to be added to a temporary array list in order to be accounted for at a later time after n cooling period time interval has been met. So add the remaining frequency instances to a temporary array list. Now, since no two same tasks can occur within an n cooling interval, we'll have to iterate up to a cooling interval n while examining each entry of this priority queue. So iterate up to cooling period n. So let's iterate up to cooling period n. Declaring iterating variable and our temporary array list. Now you'd want to have a resultant time interval variable which you would increment after accounting for each task, and that shall be eventually returned. Now before polling from the queue, you need to ensure that the queue is not empty. So you check if there are any more number of instances of that task left, we add back the remaining instances to the temporary array list, else we just poll. So in order to achieve that, we check whether the peak element is greater than 1, in which case there is some more instances after polling the current instance. So we add back the remaining instances to our temporary array list. Else, there was only one instance of that particular task, so nothing to add back to a temporary array list, so we can just go ahead and directly account for it by polling it from the queue. With that done, we increment our resultant time interval in order to account for the particular instance of task that we just accounted for previously. Now, we need to come up with a terminating condition for the current iteration, at which point we would have exhausted all the remaining instances of all the tasks in our given input. And that would happen when our priority queue is empty and there are no more instances of any other task present in our temporary array list. So translating that into queue code, if priority queue is empty and then temp size is 0, go ahead and break. Otherwise, we increment the iterating variable I in order to reach up to the cooling interval n. So after the cooling interval has been reached, we need to remember to add the remaining instances of the tasks accounted for back to the queue. With that done, again the queue would not remain empty, so this loop would continue for another um, another set of iteration up to the cooling interval. Each time queue would be polled if it is not empty, and added remaining instances would be added to a temporary array list, and a time interval will be incremented and until the terminating condition is reached. So once we come out of the outer iterating loop, we can be sure that the both the queue and the temporary array list would be empty, and therefore all the instances of all the tasks has been accounted for, and hence we can go ahead and return our number of intervals as a resultant time. So let's go ahead and run this. Now works for the given input test case. Let's go ahead and submit. Is passed. So now to examine the time complexity of this solution, since we need to iterate through the given n number of instances of the given task, so there is a time incurred of n, and since we add to the priority queue the number of instances of each task, which could potentially be one instance of 26 tasks, therefore this can in the worst case be log of 26. And space complexity would be, since we use a frequency array in order to compute the number of instances of each task, this can also be potentially one instance of each of the A to Z tasks. Therefore, so for space can also be up to O of 26. And for practical purposes, this can be inferred as O of n, since log 26 is a constant, and space can be inferred as O of 1. Thank you.